let's solve a problem using the law of conservation of energy. So in this problem we have a 70 kilogram skier that begins from rest at the top of a 36-meter high slope. She glides down the hill and 10 joules of energy are dissipated by friction. Find her velocity at the bottom of the hill. We need to read through this and extract the facts from what we see. She's a 70 kilogram skier, so her mass will be important later. It says that she begins from rest, so the first piece of information we have is that her starting velocity is 0. Next, it says she begins from the top of a 36-meter tall slope, so we know that her starting position is 36 meters high. As she glides downhill, 10 joules of energy are dissipated by friction. So we know that when she gets to the bottom of the hill, 10 joules of energy have been dissipated, so we record that information. We need to find her velocity at the bottom of the hill. If she's at the bottom of the hill, then that indicates that the position at the bottom of the hill is h equals 0. So we have all of these variables now to work with for the problem. Next, let's look at these two facts. We know that the mechanical energy at the beginning of the problem will be equal to the mechanical energy at the end of the problem. We can eliminate pieces of information just by understanding what's happening in the problem. Clearly, we've shown already that the gravitational potential energy at the bottom of the hill will be 0 because she's reached the 0 position. In addition, we have no elastic energy, so the elastic energy terms both need to come out of this equation. The next thing we can observe is that there should be no dissipated energy at the beginning of the problem because we haven't had energy wasted yet. So when you set up these problems, you'll never have a value for dissipated energy for the starting position of the problem. The last thing we want to notice is that the velocity at the beginning is 0, so that should tell you that the kinetic energy at the beginning is 0. So very quickly we have many fewer terms to deal with than it looks like we might have had to begin with. We only have gravitational potential energy at the beginning and kinetic energy and dissipated energy at the end. So we take those two equations and we set them equal to each other because that's what the law of conservation of energy says, that the energy at the beginning or at any point will be equal to the energy at any other point. So we know we can set these two equal to each other. There's no point in having these mechanical energy statements in here, so our next step will be to drop those out. So we're simply left with what you see up here at the top, that the gravitational potential energy at the beginning will be equal to the kinetic energy at the end plus the dissipated energy at the end. So let's start filling in the values into this equation. We need to first put in the formulas for them. So we'll replace E grav with mgh. We'll replace E sub k, kinetic energy, with its formula, 1/2 mv squared. And dissipated energy is an amount that we were provided. So we will be able to put that value in that location in the equation. So as we drop the values in each place that they belong, mass is 70 kilograms, acceleration of gravity 9.8 meters per second squared, and the beginning height from the gravitational field was 36 meters. We set that equal to 1/2 the mass of the skier times the velocity squared. The velocity is what we're looking for. Remember, right here at the top of the problem it says find her velocity at the bottom of the hill. So we leave the v in there since that's the value we're looking for. Then we know that dissipated energy was 10 joules. So we put that value in for 10 joules. So now we're ready to solve numerically. This is pretty straightforward. We multiply everything on the left side of the equation and we find that we have 24,696 joules. Also in this step, I took 1/2 of 70 kilograms and got 35 kilograms. The next step was to subtract 10 joules from each side of the equation. So the 10 joules on this side is gone, and now I have 24,686 joules on the left side. From this step to this step, I divided both sides of the equation by 35 kilograms. So when I divided 24,686 by 35, I got 705.6. We're almost finished. I didn't want to know what her velocity squared was. I want to know what her velocity is. So by taking the square root of both sides, I find out that the velocity of the skier when she gets to the bottom of the hill is 26.6 meters per second. So to repeat how that works, her velocity is 26.6 meters per second. Play this over again if you need to review any parts of it, and good luck as you work on